Hi there. Something special today in the lab, special for me at least. We're going to have a look at this Brymen BM789 multimeter. This is a super sophisticated, loaded with features device. We'll have a look at as many features as possible. The reason why it's exciting is because for a long time, this Fluke 117 has been my go-to meter in the lab, and it is a solid meter. I have been hearing a lot about this BM789 and about the Brymen meters in general. And so I thought, okay, well, let's have a look. And from everything that I've read and watched, it may turn out that this BM789 displaces the Fluke as the top meter here in the lab. So we'll see that. Something else that I'm introducing in this video, I've got a couple of these reference boards. So this is an AD584 reference board for voltage. That's why it's got a bunch of pigtails hooked up to it. And then I've got another reference board here for resistance and capacitance. So someone has measured these with a highly accurate multimeter, and they've written down the measurements. We'll see how the Brymen does with these, and I'm going to be using these in all of my future videos as well to test just how accurate the meters are. Before I get started, I just wanted to say that if you found this video to be helpful, please give it a thumbs up and subscribe to the channel. Questions and comments are always welcome. The feedback is appreciated and it helps me figure out where to focus my activity. One thing I should mention is that getting these Brymen meters in North America is a little bit of a interesting adventure because they're not widely distributed in North America. And I had to order this meter from TME in Poland, and I did pay for this meter with my own funds. Now let's get into the box. So we've got a pair of Energizer batteries. Okay, let's just dump it all out here. There's the 789 itself, and it's the rubber overmold is a little darker than it appeared in a lot of the videos that I've watched. What else is in the box here? There is a bunch of stuff in here. Oh. So there is a probe. Feels very nice. So that's a silicon probe, and it looks like it has a gold tip. That's the black, the red, and these really do feel like they're silicon. So that's nice. There's a thermocouple, and the thermocouple has a nice plug on it. A lot of other multimeters, the black and the red wires for the thermocouple are just sort of flopping around in the breeze, so to speak. So this is an example of the typical kind of thermocouple connection that you get. Like I said, they just sort of flop around. And so it's nice to get something that's wired up. Let's take that out of the bag. It's nice to get something with more of a socket to it. And one of the interesting things about the Brymen meter, a couple of them, this one included, has the ability to take two thermocouples. So if you need to measure temperature, you can measure temperature from two sources at once, which is kind of a neat thing. In the box, it only comes with the one thermocouple. And there are a couple of sheaths here that we can slip on to the probes. Now maybe that's when we can unscrew. So the banana jack style end unscrews, and then we can slide that one on. And so then we have a very well sheathed probe. And of course that is super snug, and that's probably why there are these little notches here to help us slide that off. I'm not sure if I want you to watch me struggle with that. Oh, comes off without too much trouble. So that's nice. It's nice to be able to have that. And of course, if I didn't mention it already, these probes appear to be gold plated, which is good because that makes a difference in terms of the, you know, connectivity and contactivity. I'm not exactly sure what word to use. And then in the box, we've got some, looks like Polish instructions, which kind of makes sense because it came from Poland, and a set of English instructions, and that is all English. One of the things, and I think it's visible on the back, yeah, one of the things to point out here, and if I can get the angle right, there you see it. So you can see that this has a UL mark, and that UL mark is good for Canada and the US, which is fantastic. I like seeing devices that are UL certified, but it's a little bit puzzling then that it's so tricky to get these in Canada and the US. But anyways, I can't complain. And that's everything in the box. So now I'm going to put the batteries into the meter and we'll fire it out. The batteries go into this compartment here at the back, and there are two screws that hold the compartment in place. That comes out nicely, and we can see that the batteries are going to go in there. Let's put those in. So the batteries are here in the compartment, and then this slots in like so. The batteries are in. Let's peel away the protective film, and we'll turn it on for the first time just to have a look at the display. This is a 60,000 count meter, and you can also see that to go along with that 60,000 counts, it has a lot of digits of precision. Now, the number of digits of precision varies a little bit between modes. So in voltage, we've got the 5 digits here. Starting with DC voltage, I've got this precision voltage reference source, and you might not be able to read the markings on it. I will put the values that are written down here on the overlay so that you can see them, because it is a little bit hard to read. So starting at 2.5 volts, we've got 2.499 here on the Brymen, 2.5 on the Fluke. The extra precision on the Brymen allows us to see the more accurate voltage. Let's go up to the next one at 5 volts. So this is now 5 volts, and so the Fluke is showing 5.0 volts dead on. The calibration source shows 3 zeros and a 7, and the Brymen is showing exactly that. Let's go to the next step at 7.5 volts. So the Fluke is showing 7.5 volts. The reference source shows that it was 74986. We've got here 7495 or 6. So a little more accurate once again on the Brymen. Of course, because it's a 60,000 count meter, we're losing that first leading digit, so it's shown as a 0. Now we're going to go up to 10 volts, and the Fluke is showing exactly 10 volts. The calibration reference here shows 10.001. The Brymen here is off by about 4 millivolts. whereas on the Fluke, we can't really tell. It could be off by the same amount. It could be more accurate. We can't really tell because we don't have the same number of digits of precision on the Fluke. 3 out of 4, certainly we've seen the case that the Brymen is more accurate, and in the fourth, hard to tell just because of the rounding that might be taking place. We're set up for AC volts. The power's off right now. They're both showing about the same level of ghost voltage. If I turn the power on, they're both showing 121 volts. The Brymen touch higher there, about 1/10 of a volt higher from what we can tell. And the thing to look at is how long does it take for the reading to click in here. So the performance of the Fluke and the Brymen seem to be about equivalent in terms of settling in to the current AC voltage. Now with the power on, let's look at the frequency. With the Fluke, I can switch to frequency by pressing the yellow button, and we can see the frequency comes up pretty quickly. On the Brymen, I press that button, and the frequency comes up pretty quickly. And we can see that we got, once again, a little more precision on the Brymen, but the Fluke and the Brymen pretty much agree on the frequency. Nice to see. For resistance, we're going to use this reference board. The actual measured values are down here, and I've placed them in the text overlay in order just so I can talk to these. This is supposed to be 10 ohms, 100 ohms, 1K ohm, 10K ohm, and 100K ohm. And so we'll see what comes up as we go through each of these, and I'll call out which one I'm on in case my hands obscure it. Oops. So that's 10 ohms, 100 ohms, 1K, 10K, and 100K. And the Brymen is extremely close to the values measured here on the board. Let's do the same test with the Fluke. I've transferred the probes over from the Brymen to the Fluke, so people can't blame differences on the probes. So let's start here now. This is 10 ohms, 100, 1K, 10K, and 100K. And so the Fluke, with its reduced precision, because it's only got 4 digits, that pretty much matched what I was calling out. But if you look at what the numbers were in the overlay, you can see that the Brymen was closer to the actual values that were measured with a much higher precision meter by the vendor. If you've seen some of my other multimeter videos, you know that I'm a big fan of the continuity test. So I've got the Brymen hooked up in continuity mode, and I'm now going to sort of slap these probes together. So I'm trying to do this as absolutely as fast as I can, and you can maybe catch that the display lights up too. So the Brymen is fantastic. Now let's have a look at the Fluke. As I mentioned, if you've been watching these, you know that the Fluke is really, really fast as well. Let's see if we can get it to skip a beat. Well, I'd call that a tie. I could not get the Fluke to miss a beat with these probes. So any problems I've ever had in the past are probably more a result of the probes than of the ability of the Fluke. So in the continuity space, definitely a tie. On capacitance, on the reference board, we've got 100 picofarads, which would correspond to 0.1 nanofarads. We've got 1 nanofarad, 10 nanofarads, 100 nanofarads, 1,000 nanofarads, or 1 microfarad, and 10 microfarads for this large one. So I'm just going to call them out. Now, it's going to be a little slower here because when measuring capacitance, there's a little bit of a charge time involved. So we'll have to pay attention to when the measurement stabilizes. So that's supposed to be 101 picofarads or 0.101 nanofarads. This is 100 nanofarads. 10. 100 nanofarads. 1,000 nanofarads, or 1 microfarad, and 10 microfarads. And you can see those in comparison with the numbers in the overlay. Now let's switch over to the Fluke. So that's 100 picofarads. You can see the Fluke is having a little bit of difficulty registering at that low range. Then we've got 1 nanofarad. 10 nanofarads. 100 nanofarads. 1,000 nanofarads, or 1 micro. And 10 microfarads. Once again, just a little more accuracy all around in the Brymen here. Now we're going to have a look at diode check. I haven't turned the meter on yet because there's something that I want you to notice when we go into the diode check mode. So diode check mode is on this position of the dial, which corresponds to both diode check and capacitance. Capacitance is sort of the default because it's the one that's indicated in white, as opposed to the diode check, which is indicated in yellow. However, the Brymen has a really great feature, which is for all of these settings where there are multiple options available on each of the dial positions, the Brymen remembers what the last one used was, and so when I go into diode check mode, it remembers that it was last diode check. And if I go into capacitance mode and then turn it off and turn it back on, it's in capacitance mode again. So that's kind of handy. If you've been doing something continually, you don't have to kind of turn it on and switch modes to get there. You just have to turn it on to the setting. Now the Fluke, I'm sorry to say, the Fluke doesn't do that. So right now, you'll see the diode check is the primary thing here. So I can go to diode check. And so it's in diode check right now. And I can press the orange button, and that takes me into capacitance. Now if I turn it off, and turn it back on, I'm in diode check again. as opposed to being in the last mode that I'd used, which was capacitance. So maybe that's fine, maybe that's not fine, but it is something I wanted to point out. So now let's look at the operation of diode check. And I've created a little kind of test gizmo here in order to be able to sort of see what happens at the different values. And so I've got, there's a Schottky diode there at the 0.2 volt setting. There's a, I believe it's a Zener diode here at the 0.58 volt setting, and then a bunch of LEDs here, red, yellow, green, blue, and white. And these all have different forward voltages. And then I've created another position here for ground and a short. Well, ground is over here, but the short. And that's because these meters in diode check have a certain behavior. And the Brymen, as you'll see, and the Fluke are identical in this sort of behavior. So let's first go through the regular things. And so now, one thing I should mention is that these values for the forward voltages, they'll vary by meter, and that's not a big deal. With diode check, the main thing we want to know is, do we have a reasonable forward voltage, or do we not have a forward voltage? And so most of the time, what we're looking for, especially for functional diodes, will have a forward voltage somewhere around 0.8 of a volt. And so 0.8 of a volt or 800 millivolts means that the diode is operating correctly. And in that case, you can see that the Brymen here, it beeps to indicate that these are good diodes. And the Fluke, which I've got in diode check mode, it does the same thing. Beeps a little softer, might be hard to hear. But the Fluke does have a little beep there when the diode is found to be operating properly, although the voltages, the forward voltages it finds are a little different, and that's just because the sampling voltage and current that the meter puts out is a little different, and these diodes react differently. Then with the LEDs, what we're interested in a little bit is not so much the forward voltage, although that is a little bit of interest to us, but what we are interested in is, does the meter in diode check mode is actually capable of lighting up these diodes, which is kind of an interesting thing. So we should be able to see this on the video. So we can see the red lights up nicely, the yellow nicely, the green kind of dim on the green, the blue lights up nicely, and the white lights up nicely. Now if we do this with the Fluke, red nice, yellow nice, green same sort of thing, blue pretty dim, and the white a little dimmer. So the Fluke is putting out a little less to light up the diodes. And then the last thing that I wanted to have here is the short. And let's see what happens when we go to a short. So this position is just shorted out to the grounding bar inside. And so when I do that, I get the shorting continuity circuit sound. And that's really handy because when you're doing some testing, the beeping and the blips and the long beeps, the Fluke, by the way, it does the same thing. That's really handy because really when you're going through checking diodes, you don't really care about the exact value. What you kind of care about is the forward voltage in a reasonable range, or has the diode failed? And usually when diodes fail, they can fail open or they can fail closed. And so if they fail closed, which is shorted, we're going to get a long beep. Great. And if they fail open, we would get no beep. So, I mean, that's like lighting up one of these diodes. But these, sorry, LEDs. LEDs, because of their higher voltage, don't operate the same way. But we could find that it's open, in which case we get no sound when we test, or we get the quick beep when we test. And so that saves us from having to keep looking at the screen when we're in diode check mode to tell, is this a good diode? Has it shorted, or has it failed in some other fashion? So that's I find that a very important feature for something that you're going to use frequently. Like I say, the Brymen, the Fluke, they both operate the same way, but not all meters do. So let's look at an example quickly of a meter that doesn't work that way. So I brought in this Unity 61E, which is another highly regarded multimeter, reasonably low-cost multimeter, not terrible, but this is a well-regarded multimeter in the hobbyist space. And so we can see that it works fine in the sense that it's measuring the diodes and it's showing reasonable forward voltages for these diodes, and it lights up the LEDs. And if I short it out, I get a continuity beep, but I don't get that quick blip that tells me it's a good diode. And that means that if I'm going through and testing a lot of diodes in a circuit, I have to keep looking at the display to tell if that's a good diode or not. And so that's that quick beep that tells you that yes, this is a good diode with a reasonable forward voltage. I think that's a very valuable feature, and one that I'm happy to see that the Brymen 789 has. And in fact, this is one of the things that's different between the 789 and Brymen's more expensive model, the 869, and one of the reasons why I didn't get the 869, because the 869 doesn't have this particular beep on diode check and mode. Brymen calls it the beep lit. That's the name of their feature when the meter operates that way. And so something to consider if you're selecting meters. Now we're going to have a look at current. And so there's a little test circuit here, very little test circuit. It's a 150 ohm resistor, and this power supply puts about 5 volts out. We have to set up so that the meter is in series with the rest of the circuit in order to measure the current. Now, when we plug this in, we plug in the common, and we turn the meter, we can turn it here to the amp or milliamp range. One of the things to notice is when I plug the probe in to the amp range, the Brymen here can detect that it's the amp range. If I plug it here into the milliamp range, it detects that it's the milliamp range. So we're going to start out in the amp range, and now I'm going to turn on the circuit. If we were to do this calculation with Ohm's law, we would come out with about 32 or 33 milliamps. Let's look at what we get when we have the circuit on here. So we've got 31.6 amps, sorry, 31.6 milliamps. Notice where the decimal point is. So the circuits, maybe the resistance is warming up a little bit as the circuit is on. So almost 32 milliamps coming in, which is close to what we would expect, or pretty much what we would expect. Now, if we move the probes over onto the Fluke only has an amp range. And so we'll move the probes over onto the Fluke. And because the Fluke has fewer digits of precision, it shows us 32 milliamps, once again, in the amp range. Now, going back to the Brymen, once again, this is the amp range, so 31.7 milliamps. But we can also go into the milliamp range, and that'll show us a sort of a more accurate, if you will, reading, because it introduces more digits of precision. One thing to mention about the probes on the Brymen, if I have the probes plugged in for a current reading and we're set into a current mode, everything is cool. If I were to have the probes plugged in for a current reading like this, but go into a voltage or ohm setting like that, I get an input error message and quite a loud beep that you can hear. And that's intended to prevent going into a situation where we've got the probe in an amp socket and we're going to go and measure a voltage. We're not really expecting that, and there could be a large surge of current, an unexpected surge of current that could blow the fuse if we do that. Whereas the flip side, if we were to go into the voltage reading, okay, so that's where the probe should be for a voltage reading. But when we go into a current reading, we don't get any sort of error. At this point, the meter's not looking at this input. The meter is looking for inputs over here, and this input's not connected. And so having the probe connected over here, we're just not going to read anything because it's expecting the reading there. Non-contact voltage, I'm going to use this wire. This is the hot line, neutral, ground and neutral over here. We're going to put the Brymen in to electrical field mode. We turn it on, and this switches into the electrical field mode. And for the Fluke, we turn it down to volt alert. So they both start out in high sensitivity mode. And as I bring these across, you can see the Fluke, very sensitive. The Brymen starts to beep. The sensor for the Brymen is over here on the right-hand side. And so as I bring that to the sensor on the right-hand side, you can see, similar to the Fluke, although the Fluke doesn't show any level of intensity. It's just there's voltage there or not. Whereas with the Brymen, we get a bar graph, if you will, and a beeping depending upon how close the hot is to the sensor. Now we can also switch the Fluke into lower sensitivity mode range, and the Brymen also can go into a lower sensitivity mode. And so you've usually got to be pretty close here on the Fluke. Similarly to the Brymen, you've got to be close to the sensor. So I'm not a big fan of this low sensitivity mode because it's pretty often hard to get there, but I guess if you're in a noisy environment with a lot of wires, this might help with the discrimination. So I prefer using the high sensitivity here and here. So the one thing about the Brymen that's not so great is that the place that you'd expect the non-contact sensor to be would be here in front. And of course, that's just not where the sensor is on the Brymen. That's the natural location, but it's actually here at the side. And so you've just got to make sure that you know where it is. The Brymen also has a live wire detection feature. And so we take the, usually the ground cord, we plug it in here. And now we can take this probe and we can stick it in to a socket here. So ground, that shows a little bit of ghost voltage. Neutral, a little bit of ghosting. But the live really reacts quite right away. And in fact, when we have the live, it sets up enough of a field that even the Fluke detects that there's a current flowing there. And so that's how the hot wire detection works on the Brymen. Temperature measurement on the Brymen, we have our thermocouple here. We have to plug this in, and remember this red dot needs to go in the red socket for it to work properly. And we can turn this over to temperature. And so now we can see it's showing there's a T1 on the side there. You can see it, T1. This unit can accommodate 2 of these thermocouples. I'm now going to touch the thermocouple. You can see it's quite fast and reactive. It's showing a much warmer temperature. I've got a really hot spot over here. So you can see the thermocouple reacts fairly quickly. If I had another thermocouple, I could use this button here, which is labeled range, but that switches now to T2. It's blank because there's no temperature probe. And then this switches to what's called T1 minus T2. So that allows me to measure the difference in temperature between 2 points and see the difference in temperature. And then that cycles back to T1. And once again, if I touch the probe there, it warms it up nicely. And you can see it really reacts very quickly to temperature changes. Now we're going to look at a few other specialized features of the Brymen. So I've hooked it up to read voltage. These features only work in some of the modes, voltage being one of them. I need to be into DC voltage. And so the inputs are connected to my bench power supply, and it's set to 3 volts, and I've turned it on. And so you can see the Brymen now is showing almost 3 volts, pretty close to what the bench supply is showing. And so the first thing I'm going to show off is the hold function. So if I press hold, the H appears in the display. And if the voltage changes, so the voltage is now 9 volts, that initial 3 volts is locked in by the hold function. Now that's pretty useful, but sometimes you have a voltage that's changing and you want to be able to see those sort of stable voltage plateaus as the voltage changes per se. And so the Brymen has something called Autohold. And so in Autohold, you can see right now it's locked into the 9 volts, but if we pull this up to 15 volts, now it's locked into the 15 volts, and now I'm changing the voltage. You can't really tell, but because the voltage is changing, I'm just turning the dial back and forth. Because that voltage is changing, the auto hold is not moving off of the initial 15 volts. But if I settle this in at, let's say, 7 volts, now it settles in at 7 volts because the voltage stabilized for a period of time. And so that's how the auto hold works. It locks in a value as long as the reading is stable for, I think, a couple of seconds. Now, another related measurement, so let's get out of this mode, is something called Crest. So right now, the bench supply is at 7 volts. We're showing close to 7 volts here on the Brymen. When I switch to Crest mode, the Crest mode is intended to show a peak, a max, or a min. So it's kind of like a peak hold, but the voltage has to be at that peak for a quarter of a second. So right now it's showing it was at that peak. I'm going to turn it up. So now I'm at this, I'm 14, 17, 14, 17. So, but if I stabilize and now, so it's kind of like max, it's a combination of auto hold and max. So it shows the maximum. Now I'm changing the voltage, but it's below the maximum. And so it's not going to lock in a new value of max. But if I go up here higher, I'm now changing it around 20 volts. But if I stabilize for a second, then it picks up that new maximum. Now I've gone below, and so that stays locked in. And so Crest is kind of like auto hold, but for a max or for a min. Okay, so there's a min. You can see it had a minimum that it hit while we were doing all of that as well. Another mode on the Brymen is this record range mode, and it's kind of like a max min averaging mode. So let's turn it on. And so that's going to look for a max and a min. And once again, there is this kind of lock-in necessity. So if the voltage changes in a sort of a willy-nilly fashion very rapidly, just like the Crest and the auto hold, it's not going to change. But if the voltage stabilizes for a moment, it'll find that and it'll lock into a new maximum. And then if the voltage changes again and stabilizes, it'll lock into a new maximum. And if the voltage is changing rapidly, it's not going to do that. Now, it beeps every time it locks into a new value. And the other thing is, once it's been doing these things, okay, so it's going to lock into a new thing, I can press this button to show me what the maximum was over this time period, so 13.99 volts, the minimum, which was 2.99 volts, and then the average voltage over that time period. And so if there's some changing voltages going on and I want to be able to catch what's going on and figure out what the maximum was and what the minimum was, and maybe I'm interested in that average voltage, that's what this recording max min average mode can do. Now the Brymen comes with a very nice set of silicone flexible probes, gold tipped, and the resistance of those probes is not, doesn't even register. But if we use some other probes here, you can see that we've got about a 0.2 ohm resistance on the probes. And let's say we want to account and zero that out, so we're not measuring the resistance out of the probes. We can use this delta function. And so that basically removes the resistance at that point, in a sense. And now it measures the difference between what we had been measuring and that delta point, and there's a little delta that appears in the bottom left corner to show that we're in the delta mode. And we can of course press delta again. We're out of that mode. Press it again, and you can see that it is a way of compensating for a reading, and we want to sort of either compensate for a resistance or compensate for a voltage, and we want to see what the value is, the changed value is from some sort of a base. I've gone through all of the commonly used features on the Brymen. This thing is packed with so many features that I haven't really even had a chance to go through every single one of them. So for example, dBm and conductance here and the %420 mA. There are other features that this meter is capable of, and they're perhaps a little more esoteric than the ones that we went through, but the unit is really packed with features and functions and extremely accurate. So in summary, the Brymen is a really super capable multimeter. Compared to the Fluke, almost every feature that we went through in the Brymen is superior, with the exception of, I think, the volt alert. I really like the way the volt alert works on the Fluke better than the way that the non-contact voltage works in the Brymen, because it's hard to remember that the sensor is here on the right-hand side of the display. I've also got to mention that the Brymen comes with a fantastic set of probes. These probes are fully silicon probes. Even the grips, if you will, are silicon. The wires are very flexible, and the tips are gold-plated. And so these are really a fantastic set of probes, and it's terrific that these probes come with the Brymen out of the box. Another very nice feature of the Brymen that's worth mentioning again is that if you plug the connector into the wrong spot, it will give you an alarm to tell you that you've done the wrong thing. So overall, really, really nice meter. If you found this review to be helpful, please give it a thumbs up and subscribe to my channel. Thanks for watching, and until next time.